Need the light, obviously. Here we go. I was going to spend some time screwing around with the stream setup this morning, but we actually have something more important to do. Good morning, everybody. It's Alex. It's Friday, and we're almost there. We're almost out of the woods on our grand refactoring episode here. We finally cleaned up the whole logging portion and string building portion of the code base. So if you look here, we have our debug console attached. And if I hit R, resets. Oh, that is awesome. And it is now totally kind of our code path going through C runtime, but everything above that is now fully kind of understood by me, which is huge, very very good, and it's what we've been really looking for. Now that include there was not what we were. That's not supposed to be there. Will we still compile without that? We should, because we're linking to the whole. We're including the whole Windows header. Yeah, we're fine. All right, excellent. Yeah, because I think the. Oh, look at this. This is the whole string file now. This was like the longest freaking thing. It was like 500 lines of just like a lot of stuff, to help with Charlie's string type that we were not really using or going to need, and so now it's just this. It is just this fixed length strings, and then we have two little output things we're just presetting it to. We will not worry about abstracting out like the process handle to pipe crap out to, because we don't care. We're not using that. Yeah, so very very cool. And now you may have just seen the very last thing is we have to fix we have some bugs right now in the renderer. It's not really in the renderer, but it is in the texture mapper, unfortunately. And it's all kind of like skill issue on my end of we're most of the way through moving everything to be using just our one texture atlas that we're loading to memory at the start of the game, or we're loading into GPU memory as a direct 3D texture 2D, right? So it's mapped there. And right now the problem has been just trying to correctly UV chord into it, because it's like a 1024 by 1024 image itself, with 64 by 64 grids. So we need to go. I had to do some math. It's not very good at math, and that's likely where our bug is right now. To tell us where in NDC, but really it's NPC, normalized picture coordinates or normalized image coordinates, whatever. I'm pretty sure these need to be in normalized chords, right? To actually sample from the texture correctly. So I have this, right, and we've added the texture UV. Oh my god, this AI crap makes my hair look kind of just, all right, whatever. But we've added that as a field into like our entity struct. We have this conversion here, which I'm guessing is probably wrong. I'm guessing it's like totally bullshit. And that's likely the source of our problem here. See, that totally would be a problem. Why the fuck is that not, what? uh, hmm, hmm. Is this, oh, does this not, okay, that might be the problem. The problem may be right here. Equals, do I still have that? No, just like, just say it. Say it, don't spray it, boys. Oh, and before I forget, I think my coffee should be ready. So, actually, we'll look at this. No. Are you serious? Oh, maybe this is a vector for I by default. Ah, crap. No, it's a float. All right, let's get the coffee, and then we'll do some hard thinking here. All right. So, if you would like to get the day started off right, all you need for that is your favorite drink of choice. Today it's coffee because I did not sleep very well. so I need the boost. And we'll all sip together. Mmm. Delicious. Okay. So what gives? Why on earth would this be would that be invalid? Unable to find type. How? I don't understand, right? Why is this not? Can I actually look at like RAX here? RAX is a U64. I have to learn. I have to remember. When you're reading assembly. Oh, whoa, what? There we go. When you're reading assembly, which one is the output? I'm assuming first is output, second. Oh no, copied into operand one. Okay. So keyword pointer. Whoops. Whoops. Can I do that? No. Because we're looking at. Can I star RAX here? All right. Or I guess we look into memory for this copy value. So here we go. So 80BF. And we've got, let's see. So what will we expect? We expect, because right now, oh, sorry. Right now, everything is all of like the texture UVs are the whole thing. Oh, but that's oh, you know what? So we do have an input error here. Uh, because I think I just hard coded them all to be 0 to 1. Yeah. So because we want to just have out here. Or we need to figure out where like this cutover is going to happen from pixel chords on the thing to I don't know why I still can't look at that. It's really annoying. Oh wait. Type format as small. Okay, whatever. Oh, there we go. Awesome. Okay, so that was the like initial part of the error. So now hmm not quite right, boys. Not quite right. Really truly handmade software? Yes. I went with these hands and I flipped all of the transistors myself to the correct values. No, but we are doing things in the Handmade Hero style. Kind of all in C from scratch. Using like as few external dependencies as possible. Right now, the only things we're really using is, we're on Windows, so we're using Win32 API and the C runtime library, as well as Sean Barrett's just image decoding library, just like the single header one, just so that we don't have to write a PNG decoder ourselves. But yeah, here's where we're at right now. Is I'm trying to take my previously we were all set up to grab a single 2D texture and just pump that to the GPU and then draw everything using that. And now I'm trying to move us over to like a sprite atlas style here where we're sampling from pieces of it. And clearly that didn't work. And I'm trying to determine why. Do you Yeah, there's something like that. Something like that. There's a little code starter in here I have to keep alive every couple of months, or else it'll start turning into Rust, I guess. Um, yeah, so I don't quite know why why it's drawing this like angle bracket here. That's like a little weird looking. Um, because I would expect, because I'm sampling from 0 to, or I'm not. Oh, you know what? This offset I have in here could be total garbage because I just stole that from my screen NDC code, but I don't know if that's quite right. Um, let me think. So like the conversion would be like that. Oh, you know what? It is. I think we may be seeing a vertical flip, right? Because the game right now is in uh left-hand chords with origin bottom left of the screen, but the I have a feeling PNGs are going to be um, right hand coordinate system because that's how the whole entire rest of the world operates. Yeah, it does. I'm sure it makes the transistors oxidize. Some it just cannot be good for your soul. All right, so let's think here. All right, let's ignore this vertical flip problem for now. That's something we can fix after. Why? Okay, I'm like a little pissed that my debugger is not letting me look at this value. I suppose we can step out another layer and take a look at it, but oh well. Um, but yeah, so what are we doing here? Basically, we're trying to map like where 0 is 0 and 1 is 1 is the end, right? Or 1 is the opposite corner of the thing. 1 is the width of the image. God, I'm awful at algebra. hmm. So let's see. So if I plug in 0 here, yeah, I'm not going to get 0 back out. So I think that this offset is wrong for our use case, right? So here, obviously I will get 0, assuming they have the same coordinate system. But if I get the width, then I will get 1. Yeah, okay. I don't know why I was overcomplicating that. I maybe like, and I guess we should rename this, right? Because this is a little misleading. Yeah, that's kind of not a great name to, but like it's like NDC is not quite right. Okay, let's try that. Let's see if that works. Okay, okay, that looks better, right? Because now we're not sampling from that like giant bar, which I assume was from like we had some maybe negative UV or something real effed up. Okay, so cool. We like what we see here. So let's actually try in for our player one. Let's try doing it like so. So we're sampling from the first image here. And just for reference, this is what our texture atlas looks like. Oh, actually, I think there's a white circle in here, and I think it's just my PNG viewer is bad and is not reading out alpha channels, which is really freaking lame, actually. I don't know how on earth that is. They got away with that. Um, Yeah. So the answer was no. The answer is no. There's no freaking thing. Okay, fine. Uh, okay. So let's see if that works. If that samples from our white circle correctly. I hope so. Oh, look at that! Oh, awesome! Awesome! Oh, genius. Okay, so that's huge. We got that thing working. Um, and of course, like it's all manual and terrible to do the rest of it, to actually figure out like which things in the texture atlas are where. But like that's like really the this is like the important part, I would say, is actually showing it worked. So let's look at let's try to figure out like a one that we can do. So if we have there's my base code. Is this not that one? If I open up a sprite, I can see the actual grid here. So this one is where? Oh, maybe my canvas is not the right size. Oh, yeah, it's totally not the right size. Okay, so here we go. Why is it still, I don't understand. I want it to be smaller. I want it to be smaller than that. Yes. What the heck? 520. No. 512. 512. Oh god. How can they just not do that, please? Thank you. Thank you. That'll do. Excellent. All right. So, yeah, we have this white one is the one we were sampling before. So let's try to sample this red one. I guess I was totally wrong. You were working on a game jam? That sounds fun. What's the jam? What's your game? And this is at 448. 448. So we will try that. This one. NES Jam making a movement platformer. Oh, very cool. So like is it actual like NES games or it's just NES style? Like an 8-bit jam. Also, yeah, that's cool. NES style. Okay, gotcha. Because that would be pretty wild for a game jam to have to to have to roll your own NES assembly stuff. But yeah, very very cool. So what do you do? What do you do in this platformer here? All right, we'll just add some little dots here, just so we're kind of confident in what we're doing. I don't think I even need to recompile, right? Yeah, like that. All right, so that is totally working. That is so awesome. But yes, so the assumption was correct. There is a vertical flip happening here, which I think should be pretty simple to fix. I think Sean Barrett's code just has a way for us to do that. So if we actually look at the header here, I think there is a vertical flip. Okay, here we go. Like Celeste, instead of dash, you have a really big yo-yo. Oh, that's cool. So do you like throw the yo-yo like out and you're like it's like you get like momentum from like tossing it around somewhere? Uh oh wait. So that would be pretty cool. Do that kind of stuff. You dive on it to start writing. Ah, very nice. Very cool indeed. How long is the jam go on for? Oh, wait. SE top. Bytes per pixel. Bytes per pixel, I think, is just this. Let's see if that worked. Like 10 more days. Cool. So that, okay. So that definitely fixed the vertical flip, but you know what? Oh, you know what? Because these may be sampling from 1024 on, right? So oh yeah, they totally are. So they are sampling some garbage, and that's just a little weird to see. That is what the GPU is actually looking for we're telling it to do some. Well, I guess it's just in normalized chords. Yeah, it's gonna be a little bit over 1 over there. Very cool. Are you also doing it your game handmade style, or you building it up in like an engine or something? Okay, awesome. All right, so all fixed. But this color is super crappy now. Super low contrast. Usagi engine. I never heard of Usagi engine. What is that? Rapid 2D game prototyping. Oh, cool. Very nice. Look at that. Look at that fun little space renderer there. Gotcha. It's like a Pico 8 style, right? With the like how Celeste got started. That's pretty cool. Or Love 2D. Very interesting. It's got all the things you would want in it. All in Lua. Very cool. Nice, man. Nice. To do Brett Chalupa. That's an awesome name. Oh, look at this. You got the spinning triangles. Yeah, you got the Tetris. Very cool. Very cool indeed. We're like most of the way there actually. With this thing, there's like just a couple of you know, like the now this renderer path kind of fully works. That looks like a little shuckle there. It's just going to be like actually fixing this like this UV mapping thing. And then I have to add sound. And sound is the thing I'm really just like worried about because I've played a little bit. This is not my first rodeo here in handmade game dev stuff. And sound I recall being just like a really annoying thing to deal with. Because it's also sort of tangent to all the graphics stuff. But we'll figure it out. We will do it. So why is my contrast so bad? It's because I'm like, this color blue probably is not great. It is just a pure blue. But the thing is so dark. It's so dark. So why? Because that is not what it looked like right before we did that flip too. You know what I'm saying? Which one was vertically flipped? So I think we were actually loading this one here. Also do gardening. Yeah, man, gardening. Gardening's great. Um, I think we were loading this green one maybe, and then that is actually we must have been. We must have been because this would be uh in our top left scheme, right? That would be the one. But this I'm pretty sure is like, where's the dropper? Dropper. Yeah, that is just full F, full alpha too, right? So why is it so dark? I guess that is what that blue looks like on my monitor. Maybe it's just a crappy. Maybe all blue might just suck on my monitor versus the clear color of the window. So that blue and that blue. That blue and that blue. Yeah, yeah, that does look kind of like it. Well, all right, wait. Well, let's do one where we actually just sample from the whole thing with color white. That will actually tell us like what the problem is. So yeah, I've been doing a lot of streaming. We I just moved, so that has been quite a lot. So we will let's change this really quick. I moved, and so now I've got like a big block in the mornings after my fiance leaves for work, before I have to head off to work. So it's been good. It's been a nice time to get some game dev in that's been consistent. All right, if we look at that, we look at it like freaking ants. Oh, that looks so funny. Look how small that thing is. Oh, crazy. All right, we should definitely do the other one. We should do the planet, or actually the moon, so I don't have to remember. We want this one to be color white. They probably should all be color white eventually, but anyway. Yeah, I mean, it does look a little gray, right? And it is very possible. We have a clear color where we're putting the screen to. That clear color is fucking up these colors a little bit. Because that I don't know, that does not look like the same blue to me. I'm eyedroppered, right? Okay, so oh crap, I take over the cursor. How can we do this best? Use a color something. Yeah, I'm trying, but I've skill issued myself with this. All right, how do I just paste this somewhere nice? God damn it. Oh god. Paint. Oh no, I deleted paint. Oh god. How awful. Where's green shot? Oh god, I deleted green shot. Oh, I have to use this stupid thing. So how do you... What is it? Snip and... Fuck. No, this is not... Oh god. That is... Oh. What is it? It's like snipping something? Fuck me, man. So bad. Maybe it is the same color. Because I really don't want to... My cursor is totally wrong, and I'm gonna have to go back into Windows for that. I think I will just call it and say that that's fine. I'm willing to not solve this problem right now, honestly. But we will need to pick a new color for this stupid spaceship. Okay, well, you know what? Actually, this was pretty good though. We have kind of proven out that this is working. So let's do this. Is the texture atlas working? Maybe some clear color, please. But pretty good. Okay. So what now? I think that's like most of the things I had in my clean shit up readme here. Yep. Prove that out. Oh, rendering from the font atlas. Oh god, right. I didn't do that yet. We did that one. Oh. I don't care about that. Did that. That's pretty good. That's good. Oh Lord. I'm definitely not doing controller anytime soon. Fuck that. Um, okay, but we definitely need audio. We definitely do want to be able to draw text on screen, just to like for just to help out with this for sanity's sake. Um, well, and we did that. That's awesome. Da, 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 da. Yeah. So this was like a 2 week like little sprint here, self self imposed deadline to keep the thing going. Where I wanted to go do some get like a fully working version of like the first level of the game here, um, which is requiring a lot of like physics tuning to make it feel kind of the way I want it to. Um, and like I was hitting a wall basically where it was just becoming so burdensome to have to recompile and like just move values around tiny bits to get it working that I wanted to get logging and drawing fonts kind of working pretty nicely, um, to be able to help out with that. And I think I still want that. I think I still need that in order to break through, because like what which should be happening here is I just implement like some button presses that will uh, mess with those parameters on the fly. This is where we start getting into to editor dev here. Um, but I think that's like what I want to do so that I can actually uh, really dial this in. So I guess we will have to do that. Uh, and honestly, I think the font rendering is more important than the sound effect for that. And I keep on punting direct sound because like, have you looked at this API? It's actually not that bad. It's not as bad as direct 3D, but um, it's not great. It's still annoying. Um, oh look, they have 3D sound in here. That's cool. Yeah. I wonder how that works. Buffer 3D class. Yeah, that's pretty cool. Sound cones. Oh lord. Yeah, this type of thing I really don't know. Um, but I feel like it would be giving up to just pull an Fmod at this point. And I kind of don't really want to do that. So but that is like that is a battle for another day, my man. That is a battle for another day. All right. So this is now our top level priority is font atlas render. Um. Mm, mm, mm. Yeah, and then we want to do some of this stuff will help us with this debugging and not that crap. Okay. All right. So let's get grooving here. I know you previously was using Sean Barrett's. Oh, do I not? I have this cloned. Okay. Previously was using Sean Barrett's library also to do this true type one. So I think it is worth just like a read through. Oh, that's interesting. Okay. Because so here's the. I think this is. I think like like a font atlas is almost exactly the same as just like a regular sprite atlas like we've been building here. Uh, but the difference is that it's got all this extra metadata garbage in it. Uh, right. So we do need to understand like what the hell is going on. Um. Okay. Mm-mm-mm. Individual glyphs. Da, ba, ba. So they have something that like scales. Oh my god. One of these fonts cost $48, dude. Alright. You know what? Maybe we can figure it out from just reading in here. So, there's some anti-aliasing going on. Whatever metrics and shapes is. Okay. Yeah, this library has a lot fewer contributions than the image loading one. I feel like this is a problem that far fewer people are interested in solving because it seems just annoying. Fix broken rasterizer. Okay. Well, that's good. I hope our rasterizer wasn't broken before. Yep. So that's like the same as the other Sean library. Yep. Bake the font to bitmap, produce as texture. Okay. Okay, that's cool. Um, you have to keep the buffer loaded. So he is keeping the whole thing in memory, which I think makes sense because like with the image one, the assumption is that you're going to just pass that over to GPU memory anyway. So um, the rest of the program doesn't really need to care about it, but the font, I suppose you do. Render Unicode code point to a bitmap. Now, what the hell is a Unicode code point? Riddle me this. Unique number assigned to each character. Oh, okay. That's just the number. That's just the index. So, um, code point bitmap. Character advance / position. Okay. Because like the thing with this is so just drawing a font on screen is like 5 different stupid problems. It is actually like doing the decoding of the true type font file, right? Unless we just do it like put characters into our sprite atlas, which is very very doable. We could do that. So it's that. It's actually having a font. Um, it is the string building in memory of the font. It is the putting it on the render API in the right spot and the draw API, which we have. Um, but then it is like the figuring out how how to like put that somewhere, right? And doing like line wrapping, um, and character spacing, which all sounds like kind of a pain in the ass, um, even if you have like a standard width font of that's like a lot of just like little stuff you have to do in there. And I think, it's doable. Obviously, it's doable. It's just how much time do we want to spend on that? So we'll think about it. Yeah, and then like with your drawing, like what do you like, or actually like what do you do? Um, because here we have like your string of text that you're drawing is going to be just a whole ton of draw quads back to back to back to back. Um, and the so you are indexing into, and you have to index into your thing, into the font atlas. Um, so which is like a one-time cost of we just have to do that math of how to break that atlas up after we've decoded it from TrueType, or we put it in our sprite atlas. So if it's an equal width font, then okay, like we have the ability to advance is kind of fine. Um, yeah, I mean, it's just like a bunch of spacing math, and it's just not, I've never had to do that at this level. Um, so it could be interesting, I guess, but this is the type of thing that, like, when you CSS, this is so abstracted away from you, uh, because you're basically just doing relative positioning of stuff most of the time within a bigger box. And here, our bigger box right now is the whole window. We don't really have a thing. And so that too is a consideration of, like, uh of do we have, like, should we create like a bounding box for the text, and then, like, how do you squish into that text or into that box, or let stuff come out of the side of it. uh yeah. And so there's like just a lot of questions to answer in this whole thing. um there's a lot of questions that we could be answering, but the thing that we really want is just going to be to draw, like, right now, like a XY, um at the spot on the screen we want, a XY value that's updating every frame of whether it is the impulse from gravity, or the momentum, the current momentum of the object that we care about, so of the player, right? So those are the things that, um because we're just trying to help visualize, uh all of, like, the physics components we have in order to make something that feels good, right? That's what we're trying to do here. So like, I think it is very probably pretty worth it to at least read this library, because enough of this library to understand what the problems actually are in the implementation, because there's so many things that, having looked at one of these, it is, like, there's a lot of crap in the weeds here about, like, glyph metrics and glyph shapes and stuff. So I think we need to look at this, and then we are likely going to pull it in. Okay, so let's look. So, um yeah, so Unicode code points is just like the number, which is fine. We got that. That's conceptually we understand. A glyph is a visual character shape, which again may not be equal width. They may not all be the same size, but we should pick a font that they do. Um, Glyph index, because theoretically, I suppose you could have maybe a TrueType font that does not uh, encompass all of the Unicode characters. Um, so I could see why that would be different, right? It's possible. All right, baseline. To find relatives baseline, the bottom of the uppercase characters. Okay. Yeah, that makes sense. Current point. Origin of each character, vertical position is the baseline. Okay. Used to vertically position spaced characters, right? Okay, font size in pixels or points. Yeah, that also sounds good to me. But then what is typographic points? 72 points per inch. And so what does that mean? Yeah, like what does that mean in pixels? 96 pixels per inch. Okay. Um uh okay, that's fine. That's fine. We probably will just use pixels though. Um okay. Yeah, so there is going to be some sort of text bounding box here, I suppose. That makes sense. Set the current point where the first character will appear. Okay. Okay. Use the functions with subpixel at the end. Okay. There's anti-aliasing. I'm not sure what kerning is actually. What is kerning? Oh, okay. I don't think we care about that because again, this is just for debug with like a programmer font probably. There are a lot of memory allocations. Yeah, I can see that that's likely. System uses the raw data found in the TTF without changing it, without building auxiliary data structures. Okay. That's fine. I don't really care that it's like slightly bit inefficient. That's okay. So what does that mean? What is this 5 seconds? What does this 5 seconds mean? Or like I think we're just looking at the relatives of like, but then that doesn't really tell me anything. Yeah, whatever. Okay, so let's look at this here. I think we're probably going to be using the 3D one, I guess. GL gen textures, text image 2D. Is this an open? Are these open GLs, right? Or is this Sean's API? Yeah, it's OpenGL. I'm gonna go to the bathroom real quick. I'll be right back. All right, I'm back. And yeah, I definitely was smoking something when I said the actual font bitmap doesn't have to go to the GPU. It obviously does, right? Because like we're drawing it on with the GPU. Um, but like I think the difference is that with this we need to keep all this other garbage in memory, um, because all of these characters, all of or glyphs, I suppose, all of the glyphs have all of this other freaking metadata in them of of the sizes and the what do we call it? What was it called? The baselines, right? So I think you like just cannot throw that out and just keep around the stupid, because for the image, like the PNG, we're just keeping around like the width and height of it, um in in regular memory basically, right? Everything else we just chuck over the wall. Oh, and I guess we keep the the pixel encoding of RGBA, right? Um, so if we look at in where's the C drive? If we look in here, let's try to open one up, right? Uh, yeah, I not this one. So this, um, what are we looking at? So this is showing us things in different font point sizes. Okay. Yeah, because like even, and this is like a terminal one too, but like this has some, the baseline is this like bottom of this T here, capital T, and like obviously the Q's and the J's and crap go underneath it. Is so even with that, even like, because this must be, I mean it looks like it is a equal width font, right? So let's find like an awful one. Let's find one that like like that. Yeah, like that does not look like an equal width font. Um, but it's still, we have this baseline height problem, right? That yeah, so that seems that seems like a problem there. What about that one? Okay. Um, what is this? Oh, okay. What about wingdings? Okay, maybe we use wingdings, and that kind of just solves the problem for us, because no one can tell if it's right or not anyway. And look, this one doesn't have a baseline problem. There's no baseline thing to care about, so that's good. That would simplify our life quite a bit indeed. Um, that's funny though. Look, wingdings has like all the Mac has the Mac menu characters in it. Uh-oh. Don't tell Bill Gates that. They shipped with a bunch of Apple stuff in there. Tim Apple's gonna sue. Um, I don't know why. Like, I understand why Wingdings, like why you want these characters around. It's just kind of weird to encode them, because like there's the Mac command one is split up in here. Um, I guess because it's pre-exists like Unicode emoji or whatever, right? But I don't know the story of Wingdings well enough to tell you what the hell the thinking was. Um, oh well. Oh well. Webkins. Yeah, and see like why the fuck why would you ever want this giant cruise liner character? Who has ever who has ever used this, man? I guess like these must be fallbacks for emoji. I guess that's probably the reason, but like come on. Come on. Oh, and I guess this is why they all have ABG in the thing too, is so you can see capital, you can see a lowercase, and then you can see one that goes below the baseline. That is quite interesting. I think we are finding. I think actually like looking into this was not a bad call here. Let's see. Um, all right, we got like 15 minutes here. Yeah, I think that kind of cinched it. Of like, fuck, I don't want to do this right now. um, if I look, actually, I wonder what this does look like. E slash Windows slash fonts slash. We'll just pick one. We will pick Arial, right? We'll pick regular Arial. Yeah, I mean, look at that. Fuck. How is fonting? That's fonting right there. Looks like a freaking nightmare. um, yeah. Shit. Because I think it's just like like even if you constrain it as much as possible, or actually like fonting has all of these like little tiny spacing and positioning problems, it seems, in order to get things in the right spot. So for like a title screen, I would say like even do something as stupid as like just like go in your editor and like go write out like just do a title. Of course, we're at like 7-point font here. Yeah, just do one of those, and then load the sprite in for that. Because if you have no need for text that's going to dynamically update in on that screen, then like may as well save yourself freaking trouble. Unless your Usagi engine kind of handles that for you pretty nicely. Uh, but it does seem like it is quite the hassle here. Because I wonder even like how this encoding actually works like per glyph. Of like what are we looking at? Like I think we're actually like looking at the characters here. Because it's probably, oh god, I don't even know, like, for how do these do color too, right? um because like I think it's easiest to have something white and then apply your RGBA value on top of it. um so like I would, if I were encoding a font, I would just be doing these are like pixels, right? uh this is like a K, and then maybe some of these are like rounded or something. Probably there's quite a few that are rounded because like fonts are not aliased to all hell, and they can't be when they're drawn at like 72 point or whatever. Um, so that actually is what I think. Could this? I think I think we are looking at pixels and subpixels here of like the top row of some character. Or actually, let's find a good break. Like this is probably the top row of a character. In pixels and subpixels. So like you have and who knows what the mapping is. But I think that's it. There must be like, slanty ones and like full ones. If we look toward like the middle of a character, of what is presumably a character, like okay, this character looks freaking complicated. Like what the hell is going on there? Um but if I were to like totally information theory this, I would expect you could see like if we just go back to the top. Um, well, the very top, there's probably some header encoding going on for the font. Yeah, so this is all like some header data, right? And that's probably telling your thing where everything actually lives and what the sizes of your bounding boxes of each glyph are. I would guess. Yeah, pure guess there. Um, but then if we actually start looking at some characters, uh, I would information theory expect you to see the top rows of all of them probably are going to be subpixels that are top row edged, right? Where there's more colored pixel at the bottom part of it. Um, and if you look at the left ones, you would expect similar, and then the right in the bottom. So if we look at like the top rows of a bunch of characters, I would expect to see a bunch of D, F, and G's. That would be my guess. And if we look at the bottom, maybe we see more of these H's. And then also, where is the split? That's kind of a thing I don't know. And this is like now purely a for fun exercise here because clearly we're not getting anything productive done in the next 5 minutes. But it's actually interesting. Of like this is kind of like a cool little puzzle here. Um, I was just playing Fez. I just beat Fez like a couple weeks ago, and it was kind of interesting to, from information theory, try to figure out some of like because that game has like a whole ton of this of like just language decoding stuff in it. And it's not like it's not like this crazy, but it's like a pure alphanumeric substitution one. But there's some like clever stuff in there and how it works. Uh, yeah. All right. You know what? I think we've screwed around. Looking at the byte representation of Arial enough. We should get back to this library recovery. Where were we? We were slowly coming to the realization that we really don't want to be doing this from the ground up. Okay, so here is here was Sean's example code. So he is just opening the TTF in memory, right? He was baking that into a bitmap that was binding to the hardware. Yes. And then you can free it. Yeah. But then how get baked data? Like how does it know? While text. Char star text. What is this C data static? Yeah, that's a static, or it's a global, right? Because must be where all the metadata lives. Okay, and then you give it in 32 point font. what the hell is XYQ in this context? So you give it a quad to write into. Text 32. 1 equals OpenGL and D3D 11, 10 plus. Here's D3D 9. Okay. Wait, so what is this doing? Of we are passing it, or this is making like the 4 vertexes for for this quad, and the text chords, right? So this is all the same thing. Oh, but it's looping through it. Oh, okay. Okay, so it's just looping through it and building those and doing the UV mapping from this. Okay. All right, that usage seems pretty reasonable. Seems reasonable to me. All right, what about this one? Get a single bit map, print as ASCII arts. Okay. Print hello world banner. Kern advance, right. Oh, this seems like what we want. Yeah. Okay. All right. And here's the actual interface into it. So yeah, so it looks like it's like three or four APIs we actually need to know. Again, because we will give ourselves the most the nicest version of this, where we will pick a font that does not have this like baseline problem and kerning, because like, you know, absolutely, you know, f that is totally, we totally do not want to do any of that garbage. We just want to draw 2 floats on screen, bro. 2 floats on screen. It doesn't really matter. But I think probably go ahead to pull this code in and try to figure that out. And that will probably have to happen next time, or I'll do it this weekend, because oh god, it cannot be that interesting to watch people do font rendering, can it? All right, yeah. So I'll continue reading through this. I'll continue doing all this stuff off screen. All right, we have. Oh, this is not the right spot to check. Yeah, I've got to run though. I've got work and starts in 1 minute, and I like to have a good cutoff here, uh, between streaming time and work time. So thank you very much for watching. Half Wuff. I hope you have a lot of fun with your game jam and working on your stuff. I wish you good luck with your yo-yo platformer. If you ever want, you know, like send me the link to that when it's ready. I'd love to play it, to take a look. Um, I'm back here usually every weekday from like 7:15 to 8:15 or so. And yeah, we'll keep grinding at it. So thank you very much for watching and listening. I hope you have a wonderful rest of your day, and farewell for now.